Question 4, shape T is reflected in the line x equals -1. So -1 on the x-axis is here, so a line going through that, a vertical line, will be my x equals 1. So we're literally going to follow this process here, okay? We're going to literally reflect this shape now in that mirror line here. So to do that, I prefer to just focus on the corner points, the vertices of the shape. So we've got to go, that distance there is 2 squares, so we're going to go back 2 squares, we're going to end up here. That corner point there is 3 squares from the line, so we're going to go back 3 squares, we're going to end up here. And that corner point is 4 squares from the line, so we're going to go back 4 squares from the line. Okay, so always remember now, it's not the axes, it's the actual line here. So 1, 2, 3, 4 squares, so we go back 1, 2, 3, 4 squares, and we've got our shape here, and they ask us to call that shape R. It then says the shape R is reflected in the line y equals -2. So y equals -2 is a horizontal line because it goes through -2 on the y-axis. So we're going to reflect that now in this mirror line here. So again, with the corner points, that here is, what's this, 1, 2, 3 from the line. So we go back 3 underneath then, 1, 2, 3. That corner point is 1, 2, 3. So we're going to be 1, 2, 3 down here. That corner point is quite far from the line, so it's 1, 2, 3, 4, 5. So it'll be 1, 2, 3, 4, 5. We reflected 5 that way. So that will be my shape S. Then it says describe the single transformation that will map shape T to shape S. So instead of doing these reflections that we've done here, how would you go directly from here to here? And what we need to appreciate is, if I compare this to this, it looks like it's been rotated. Yeah, it looks like it's been rotated to get from S to T. But when we do a rotation, and we can write this down, rotation, okay, but we obviously need to have more information. We need to know what it's being rotated about, where is the center of rotation. Now to do that, all you need to do is just join together the corresponding points. So if you imagine this shape rotating around, okay, so let's just trace it for a minute on my tracing paper. So trace the shape here. So if you imagine this corner point here, well, when you actually rotate it around, I don't know what point it's going to be rotated around, but when you rotate it around, that corner point will actually correspond to that point over here. Okay, so these 2 points correspond with one another, and then clearly then we can work out then the other points correspond to. So we can join them up. So that point corresponds to this point, and then of course then the apex there, they will correspond. And what you'll find is that they actually all intersect at one point here. So that will be our center of rotation. So let's just do that. So when I rotate about that point, now when I'm going to rotate about that point here with my tracing paper, I need to put it's good to put a cross here, okay, like an axis system, so I can then keep track of the rotation. So if I put my pen there, and if I rotate it, okay, so when I rotate it there, that's a 90-degree turn, isn't it? If I go back to the start, you'll see what I've done there. So a 90-degree turn because it becomes a cross again. Now I'm over there, so I need to do another 90-degree turn, and you can see then I get to the shape S. So I did 2 lots of 90-degree turn there, so that's a 180-degree turn, rotation, and it, of course, of 180 degrees about center, that center there. So the coordinate you need to write, okay, so it'll be -1, -2. That will be the coordinate there, across to -1 down to -2. Now it doesn't matter whether it's gone clockwise or anti-clockwise, okay, so 180 degrees, it really doesn't matter, doesn't it? Because you could go clockwise, like I just did, or you could have gone anti-clockwise, 180 degrees. So it's 90 and then there's another 90. So it does, with 180 degrees, it doesn't matter clockwise or anti-clockwise, so I don't need to write that there.